Welcome to the notes for objectives 5B, 5C, and 5D. And if you look through the notes, you'll see that I've actually broken it down in each section for you and wrote which objective we're talking about. Okay, so let's start with 5B. I can build a rule from a word problem. So if you have a calculation that you're going to do over and over, you can write a rule. So for instance, let's do this problem here. Convert the following to seconds. So how do we take 9 minutes and turn it into seconds? Well, we know that there's 60 seconds in a minute, so we're going to times it by 9, and we get 540 seconds. Okay, 3.5 minutes, same deal. I'm going to multiply it by 60, put it in parentheses so we don't confuse it with the decimal, and 3.5, and I get 210. And last one here, 60 times 4.1 equals 246. Okay, but if you're going to do the same thing over and over, we can create a rule to convert minutes into seconds. So what is our rule? Well, let's write the rule as an equation with an x and y. So for instance, y equals 60 times x. We have to be very clear about what's the input for the rule and what's the output. So what are they giving us is the input. And in this case, what they're giving us is the minutes. What's the output for the rule? Output is what you're trying to find. So we're given minutes and we're trying to find the seconds in this case. So we're given minutes, that's the x. The input is always x. The output is always y, what we're trying to find. Okay, so now here is one for you to try. You're going to convert the minutes to hours. So what do I need to do to this minute to get to hours? Then I want you to write the rule, and then I want you to actually tell me what each one stands for, what the input is, and remember that that is the x, so tell me what the x stands for, and what the output is, that's the y. And we'll go over that. Okay, 5C notes say, or objective says, I can determine if a relationship is a function. So what is a function? A function is a rule in which the input, so the x's, always has just one output, or y. In other words, each input must provide the same output every time. So here's some examples, and this isn't even all of them, but just 3 examples. Something that you'll see a lot is a function machine. It's just kind of showing you that what a function is just takes a number, does something to it, and something else comes out. So this is something you'll see every now and then in books and stuff, but a function machine is just kind of a silly little idea here. But if we have a function machine, and let's say that what it's doing is finding the absolute value, if I take -3 and put it into my function machine, what pops out of my function machine? A 3. Another kind of idea behind the function machine is you can think of functions just like a machine such as a toaster oven. If I put bread in the toaster oven, out pops toast. An ice machine. If I put water in my ice machine, out pops ice. So each time, the same thing happens. Okay, so a function can be also shown as in a table. For every x, there's a y. So let's say we have, and we've looked at tables before, but let's say we have these x's. And then the output, and I'm going to just use this absolute value again, the absolute value of -3 is 3. The absolute value of negative 2 is 2. The absolute value of negative 1 is 0. And we have 0, 1, 2, 3. Now, I want you to pay special attention here because it says for every input, there's always one output. That doesn't mean that you can't have y's that are the same number. What that means is if you have negative 3, the only y that can go with negative 3 is 3. The only y that can go with negative 2 is 2. You couldn't down here have another negative 2 and then say that this one's answer is 4. Any x that's negative 2 for this function, the answer is always going to be 2. Any x that's negative 1, the answer is always going to be 1. So this negative 2, where the answer is 4, wouldn't be possible. You can only have one answer. Okay, and then a function rule is kind of like what we were just looking at before when we made it from a word problem here, is just an equation. So a function rule could be y equals the absolute value of x. Okay, these are all the same function. So for this example, are the following examples of functions? So if I have a number and I add 4 to the input and square it, so I add 4 to the input and square the result, is that going to produce the same answer every time? So if I put 2 in and I add 4, 2 plus 4 is 6, and then I square the result, so I'm going to square this and I get 36. Is there any way that I could put 2 into this function? Let's make it a machine. Make a little machine around here. Okay, so I'm putting this into the function machine. Out comes 36. Is there any way I could put 2 in here and get something different? No, there's not. So this is a function. Okay, for this next one, is this a function? So let's take our same number. It doesn't matter. You don't have to use the same number, but add 4 or 3 to the input. So I'm going to make a function machine just to give you an idea here. And I put 2 in, and then I can either add 4 or I can add 3. I hope your function machine is prettier than mine. All right, so you can add 4, you can add 3. So if you were to add 4, out would pop 6. If you were to add 3, out would pop 5. So is the same thing, are you getting the same output for every input? No, you're not. So this is not a function. Okay, you have to get the same output for every input. So not a function. Okay, here's more of a real world example. Clicking the number 02 on your TV remote control and the channel that comes on. If I take my remote control and I type in these numbers, do I get a different channel every time I type it in? Well, no, you always get the same channel, whatever 02 is on your TV. So this would be a function. So yes, a function. And last one here, the page number in any book and the number of words on that page. Okay, so let's say we went to page number 2 in our math textbook, and there were 120, so page 2. Let's write this down so we can keep track of what I'm saying here. So we went to page 2, and there were 120 words on that page. And then you went to your social studies book, and you also went to page 2. But on that page, there was 320 words. Okay, so for both of these, the input is 2 for the page, but we're getting 2 different outputs here. So this one is not a function. All right, that was 5C. Let's bounce back and look at the objective for 5D. I can express a function using function notation. Okay, what is function notation? The most simple explanation is we have our equations here, such as y equals 2x plus 1. Right, this is an equation we're used to seeing. and we get rid of the y, and instead of y, we put f of x. Okay, so it's saying I have this function, and I would plug in x, and then this is the output. Okay, so the f is the name of the function. And the x is what you put in the function. And this will make more sense in just a moment. So why do we use function notation? Well, the main reason we use it is to be more specific, to give our equations more specific names. So what I mean is f of x you see pretty commonly, but if I have two equations, let's say I also have another equation that I'm working with, and I could call that equation g of x, and it could be whatever. Or you could have the equation c of x. And a lot of times this letter here will represent something like cost. So we could say cost is a function of the number of items, with x being the number of items. So let's say that something cost $2.50. We would put an x there, and then the more items we buy, the higher the cost. So it's just a way to give names to your equation. Okay, evaluating a function at a specific x. So we'll see this a lot, and we'll be given a function in function notation, and then it says find f of 2. So I'm just going to take everywhere there's an x and plug in the 2. So here there's an x, here there's an x, and here there's an x. We'll put 2 in here. Where there's an x here, I'm going to replace it by parentheses to give the 2 a home. And I'm going to copy the rest of the equation. Every place there's an x, I'm going to replace with parentheses and put in 2. And then just like that. And then when it says find f of 2, we actually have to simplify all of this. Now, nothing's going to happen on the left side. So this side stays the same. And then on this side, we want to make sure that we're always simplifying using order of operations. So simplify using PEMDAS. Let's go for it. Let's go ahead and simplify this, finding f of 2 for this function. This stays the same. All right, parentheses. Now remember, parentheses means, is there something inside the parentheses that can be reduced? There's not. Okay, so we're done with that. Exponents. So we're going to go ahead and square this here. So we have 4 plus 2 times 2 minus 1. Then we do multiplying and dividing. Well, we only have some multiplying here. When we have these parentheses mean to multiply. Doesn't mean there's something to simplify in there. So right there, I need to do some multiplying. So 4 plus 2 times 2 is 4, minus 1. There was no dividing, so we're done with those two. And then adding and subtracting. And just remember that you have to go left to right every time. Same for multiplying and dividing, but there wasn't any dividing to do. Left to right. So that means 4 plus 4 minus 1. 4 plus 4 is 8, minus 1 is 7. Okay, so when we evaluated this function at f of 2, or find f of 2, there's just a couple ways of talking about it, we came up with 7. All right, same here. Go ahead and try this one on your own. Just remember to use PEMDAS. Okay, everywhere there's an x, go ahead and plug in that 2, and then make sure that when you're simplifying this side, you use PEMDAS, and you're going to come down, you're going to end up with just one number on the right-hand side at the end. Okay, that's it for this video. If you have any questions, please put them right here, and I will answer them in class.